In this lesson, we're still going to work on being able to solve literal equations. And as we mentioned before, literal equations do not have a numeric answer. They'll have another expression for an answer with oftentimes other variables and constants with them. And we said in many areas of math and science, formulas are used to calculate information. Sometimes the formula is more useful if it's rearranged by isolating a particular variable. So here are some examples of formulas that you've seen before that contain multiple variables, and we'll probably use going forward where you have to isolate one of them, so it is more helpful for you. So let's look at these 6 formulas. Do you recognize what they represent? This one, the capital A equals LW. A, capital A like that, means area typically in mathematics. So the area is calculated by the length times the width. What could this be used for? Well, this is often used for rectangles, squares. We can even extend that to making with other shapes, but that's typically what you've used in the past. So we say capital A is area. So we have a couple other area formulas here on the left. A equals 1/2 BH. This, perhaps you recognize, is the area of a triangle, 1/2 the base times the height. Area equals S squared. This, perhaps, you would recognize that's the area of a square, the side squared, which also you could use for this as well. Here we have P equals 2L plus 2W. P in mathematics typically is perimeter, right? So the perimeter of 2 of the lengths and 2 of the widths. Well, what figures could we use that for? Things that have opposite sides that are equal, parallel sides. That could be for a rectangle. It could be for a square. Here, D equals RT. This is D for distance typically. Distance equals the rate times time. And here, capital C equals 5/9 times the quantity F minus 32. Well, capital C and F, that refers to temperature, right? Celsius to Fahrenheit. So to calculate the degrees Celsius, you could use this if you know the degrees Fahrenheit. So now we've seen some previous formulas. Let's see if we can use those to help us with our solving. So can we rearrange these equations using the steps that we usually use to solve an equation? So here, solve D equals RT for T, right? Isolate T. So again, we want to solve for T. Well, let's think about here. We have multiplication that we have to undo, so we could divide each side by R. So those would divide out and make a 1, so we'd have D over R equals T. Now D and R have no common factors, so we're going to leave that as is. Here's our literal equation, solve for T. So if I'm looking for the time and I know the distance and rate, I could put them in here and very quickly I have what I need for the time. Here's another formula, I equals PRT. We want to solve for P. So let's think about what's happening here. PRT, what operation is holding these items together? Multiplication. How do you undo multiplication? Division. So we'd have to divide each side by R and T to get P alone. You can do that one at a time. You could do it all at once. It's up to you. But remember, these will divide out and make 1. These will divide out and make 1. The left-hand side, we have no common factors to divide out, so we can leave it as is. I divided by R times T equals P. So again, if we have the values for these 3 variables, it's very easy to see what P is equal to. Here's an equation, D equals M divided by V. We want to solve for M. So let's think about what's happening to M. Division. How do you undo division? Multiplication. So if we multiply each side by V, we should have M alone. So let's multiply each side by V. And remember, we multiply across, right? So we have V times D over 1, M times V over V. Nothing here is really common factors to divide out, but we don't have to necessarily write over 1. We could just write v times d. On the right-hand side, look, they have a common factor of v that we can divide out, so we just have m, and that was the goal, to get m by itself. So m is equal to v times d. Here's our perimeter equation. We want to solve for w, the width. So let's think, how can we solve for w? Well, we have some addition that we have to undo, and a multiplication we have to undo. But the addition comes first. So we'll subtract 2l from each side of our equation. And remember, these are not like terms. We're going to have to keep them separated, right? So you could say negative 2l plus p, or p minus 2l. That would say the same thing, equals 2w. We have to undo that multiplication of 2, so we'll divide every single term by 2. And then we'll see what will occur. So let's see, we have a common factor here of 2, so those will divide out, so we'll have negative l. No common factors here, so we're going to keep it as p over 2, or maybe some of you write 1/2 p. And equals, we've got a common factor of 2 we can divide out here, so we should just have a w. So here's one way to write our equation, right? Negative l plus p over 2 equals w. Or we said you might want to write it as 1/2 p. They're saying the same thing. Here we have v equals 1/3 pi r squared h. Do you recognize what this formula represents? Well, v in mathematics means volume. So it's the volume of a figure, right? The space a 3D figure contains. Perhaps you notice this part of the equation, pi r squared, that's the area of a circle. So what 3D figures have circles in them? Well, that would be either a cylinder or a cone. This is the volume for a cone because it's tapered. That's why the 1/3 comes into play. So here we have the volume of a cone, and we want to solve for h. H represents the height. So how are we going to undo this equation to get the height of the cone alone? Well, let's think about our rules from before where we were solving equations and inequalities. First one was, if you have any fractions, how can you eliminate it? So remember, fraction is like a division. This says we're dividing by 3. Well, how do you undo division? Multiplication. So let's multiply each side of the equation by 3, so we no longer have fractions to work with. So 3 times v, that's 3v. 3 times 1/3, remember that's going to be 3 over 1, so 3 over 3, that's 1 here, and that undoes it, so we don't have any fractions to work with now. So this is good. But again, we're trying to get h alone. Well, how are these items being connected to each other? Multiplication. How do you undo multiplication? Division. We have to divide by pi and r squared to each side of the equation. So on the right-hand side, this is a common factor to divide out to make a 1. These are common factors to make a 1. We'll have h alone, which is what we needed. On the left-hand side, we double check, and there's no common factors to divide out from the numerator or the denominator, so we're going to have to leave it as is. 3v divided by pi r squared is equal to the height of your cone. R represents the radius of the circle for the base. So, again, we said oftentimes we try isolating variables so it's quicker to evaluate when we know more information about the problem. Find the height when the volume of the cone is 64 cubic inches and the radius is 9 inches. Well, if we already solved for the height, right, and we know the volume and we know the radius, we could substitute it in and find that height fairly quickly. So let's put in what we know. We know the volume is 63 cubic inches. We know the radius is 9. Well, the radius squared, 9 times 9 is 81. Now, if we evaluate what we have in the numerator and the denominator, we're going to see if we can simplify it. So let's think. 3 times 64, that's 192. And then we've got our 81 pi. Again, are there any common factors we can divide out? Well, we can divide out at least a 3, right? Because that would be there. Factor of 3. So it would be 64/27 inches, because it's a height. And that would be the exact value. Sorry, 64/27 pi inches for the height. Now, you wouldn't necessarily tell someone that you need that amount of inches. They're going to kind of be like, huh? Because usually it's an integer or a mixed number, talking about quarters, sixteenths, or as a decimal. So if we wanted to find the decimal approximation, we could do that using our calculator. We just have to be careful when we enter it into our calculator. Remember the calculator, the fraction, right, is the division. So if I take 64 divided by the quantity of 27 pi. So make sure you have parentheses around the 27 pi when you're entering that in your calculator, and that will help you get the approximate number of inches for the height. So if I do that, that's approximately 0.8 inches for the height of the cone that has a volume of 64 cubic inches and a radius of 9 inches. So this made it fairly quick. If we already had solved for the height, just substitute in what we know to find it. Now, did you have to do it this way? No, we could have went back to the original equation and substituted in the volume, substituted in the radius. But look, we have to undo it anyways to get the height alone. And we can do that. We can go through and simplify and work it out and undo it to get the height alone. But notice, look, we're at the same point as where we were previously. If you compared steps, it was a lot quicker for us once we already had the height isolated to substitute the values that we knew for the volume and the radius to get the result. So here's another good example of why we like to isolate variables, why we like to solve for literal equations, because it's less steps in our evaluation process to find a height, a volume, a radius, and so on. So let's try this one. Here we want to solve C equals 5/9 times quantity F minus 32 for F. Well, before we talked about, whenever we saw capital C and capital F, those talked about temperature, right? Celsius to Fahrenheit. Right now this is saying, you know, the degrees Celsius, or you could calculate the degrees Celsius if you do this to the degrees for Fahrenheit. So if we want to solve for F, the Fahrenheit, that means if we know the Celsius temperature, we can find the Fahrenheit temperature. So again, converting from degrees Fahrenheit to Celsius and vice versa. Well, for this one, we have to think about, well, how can we undo this? And again, there's kind of two trains of thought for it. We have a fraction here. We know we like to undo the fractions. We have a couple of options. Fractions means division. So here we're dividing by 9. How can you undo that? We can multiply by 9. So that means we'd have 9c equals, and then 9 times 5 9s. I think it was 9 and for 1. 9 times 5 is 45. 1 times 1 is 9. 45 divided by 9, that would just be 5 times your quantity, F minus 32. All right, so no fractions to deal with. Still trying to solve for F. So it's 5 times the quantity. So we could undo the multiplication by division if we'd like to do it that way. So again, here we have a common factor of 5 that we'll divide out to make a 1. So we just have F minus 32 on the right. And now we've got 9c over 5 on the left. No common factors there to divide out. So again, we're still trying to get F by itself. We can see we have some subtraction to undo. To undo subtraction, we're going to do addition. So we're going to add 32 to each side of our equation. And now we have our literal equation solved for F, right? 32 plus 9c over 5 equals F. Here's our equation. Now some of you I know, instead of writing 9c over 5, might want to write it as 9/5c. That's fine as well. Now we know there's another way that we could undo working with fractions. Instead of doing the undoing of the division and the multiplication, we also talked about how we could multiply by the reciprocal. So if we go back to that idea for the first step here, right? If we multiplied by the reciprocal, multiplying by 9/5, right? We'd have 45 over 45, which is 1. By multiplying by the reciprocal, that would bring us all the way to this step here, and we would undo it the same way as before. Is there one right way? No, both approaches would be correct. You still would end up with the same literal equation. Well, let's see, how can we use this to do some temperature conversions? Find the temperature in Fahrenheit if it's 24 degrees Celsius outside. So we're looking for the degrees Fahrenheit, right? So if we know what the degrees Celsius is, we could find the degrees Fahrenheit. So if I substitute in my degrees Celsius, that will help us find the Fahrenheit. So here I just have to multiply 9 times 24 and take that and divide it by 5, add 32, that will give me the degrees Fahrenheit. Well, we know 2, 16, and 5 do not have common factors, so we'll have to get a calculator to help us figure out the approximate temperature in Fahrenheit. And again, remember, doing it in the calculator, use parentheses around your fraction. So we could do 32 plus the quantity 216 over 5, and that would give us 75.2 degrees Fahrenheit. Now, if we didn't isolate for the degrees Fahrenheit, we could have gone back to the original equation right here, substituted our 24 degrees Celsius, but look, we still have to undo it to get the degrees Fahrenheit, just like we did before. And you can, it just, look, it results in more steps to get your result. It should still be the same, just more steps. Remember, the more steps that we have, that increases probably our likelihood or our margin of error for the problem. So we like in mathematics to simplify that process so we're more accurate with our calculations. But again, either way would get you the same result. So today again we were practicing solving your literal equations and then extending upon them to find different features out about them. You're going to do some more practice with that today.